we're heading into territory we don't fully understand. Hinton didn't leave Google out of pessimism, but out of responsibility. He saw not just potential, but peril, models that learn too fast, systems we can't fully explain, and a future we're not fully prepared to govern. But here's the truth. We can't stop the race. So let's race in the right direction with intention, trust, and collaboration. With great power comes great responsibility, and you'll recognize it. It's not just comic book wisdom. It's really the founding ethic of ethical innovation, and there's no better place to apply it than to climate crisis. At OS-Climate, we believe that AI should not live in black boxes. It must be transparent, auditable, collaborative, and open source, because the challenges we face are too complex for closed systems. That's not a theory. It's a movement we are already building. OS-Climate is building the public infrastructure for climate-aligned finance. Is it coming? Yeah, okay. I'm not going to read through the slide, but OS-Climate is hosted by the Linux Foundation, as you might know. It's a supplemental directed fund within FINOS. And our community brings together really financial institutions, regulators, developers, and technology providers to co-develop tools that are open source, regulatory aligned. We just had a meeting with a private meeting, and free from vendor lock-in. We focus on solving 3 of the sector's most urgent pain points that we keep hearing. Fragmented, low-quality ESG data. We just heard it from the regulator as well. Black box risk models that can't be explained or trusted. And inconsistent, manual, and costly reporting processes. But this isn't just about better tooling. It's about better intelligence, and this is where AI enters the equation. So the climate challenge, I think you understand better than most, is really a tech challenge for the financial sector. The complexity of the climate risk, the complexity of the data, and the complexity of analyzing that data is not just a policy problem. They don't understand how that works anymore, but it's really a problem that we can help solve with data and with solving data and infrastructure issues. So like I said, OS-Climate is building the plumbing, the data pipelines, open models, regulatory grade tooling that everybody can plug into. It's always pre-competitive, as you're used to in open source, of course. It's always collaborative, and it's radically transparent. That's also something that resonates really well with policymakers. And policymakers, while they can provide the direction, we translate that into code and not just standards. So we've all seen a lot of prototypes. What we really need now is adoption of the systems. OS-Climate has 4 main tools. I'll just show them very briefly on the screen, but the 2 tools that we're most mature on are data commons and physical risk resilience platform that we'll talk about and that Maris will talk about later. However, much of today's AI and climate conversation begins with concern over energy consumption, and rightly so. I mean, according to the International Energy Agency's Electricity 2024 report, the electricity demand for AI-driven data centers could more than double by next year. That means we must act deliberately. Every watt powering AI should be green, and every AI application should drive positive impact. So we see 4 ways that AI can do that and substantially contribute to driving forward sustainability. One is optimizing complex systems. And that's maybe less in our area, in our direct area of work, but that is where, whether it's grid balancing, regenerative farming, or supply chain logistics, AI can coordinate distributed variable systems in real time. The second one, accelerating clean tech innovation. AI is really transforming material science, enabling faster screening of alternatives for solar cells, batteries, and even low-carbon cement. Also maybe not directly our sector here today. But the last two are really the core of what we're trying to achieve here at FINOS and OS-Climate, is really faster and better data. AI can fill critical data gaps, and we just discussed it, from estimating emissions where no direct data exists to using satellite imagery for real-time biodiversity monitoring. And we're working with some companies on that already. And then maybe, last but not least, and maybe the most powerful use of AI for the financial sector is really enhancing decision intelligence. AI can help investors understand transition risk, help insurers model resilience, help corporate boards navigate ESG complexity with role-specific insights. And this is the goal of contextual AI, giving each actor in the system the most relevant signal, not just more noise. And that's why OS-Climate and Red Hat are collaborating to turn AI from an abstract force into an applied engine for climate resilient finance, grounded in open tools, trusted infrastructure, and regulatory alignment. So, to explore how this is being built in practice, I'd like to now hand over to two colleagues. And just before doing that, for completeness, I'll just show here the 4 flagship projects that we're working on. Where you have physical risk, there was a session on this a little bit earlier today, transition scenarios, portfolio alignment, and all of that is supported by the data comments that Marius will walk us through in that project. If you want to talk about any of the others, come see us afterwards. And there's, I think, one more session this afternoon on physical risk as well. And then after Marius, Richard Harmon, Vice President at Red Hat, will explain how their open infrastructure and AI expertise can help scale this responsibly across financial firms, regulators, and the real economy. Gentlemen, over to you.
Fantastic.
And I'll move the cursor so it stays awake.
Yeah. Thanks, Stephen. Hello, everyone. My name is Marius Bogovic. I'm also with Red Hat, and I lead the Data Commons project on behalf of Red Hat. And how many of you think that you have enough data and good quality data? Not a lot of hands up. The reality is that when we when we started this project, it became very, very clear that any climate-based decision, especially in investment, needs to be grounded in solid, good quality data. And the data exists. It's, different organizations publish it, they put it out there. The problem is that it's very fragmented. It's very fragmented in terms of standards and formats. It's fragmented in terms of quality. So when you're trying to build, for example, a new data set, and you're trying to infer something, for example, for combining data about, carbon emissions and the impact, for example, on sovereign bonds. You want to invest in a country that is, environmentally conscious. You have to kind of combine these things together and put them together. So this is why we developed Data Commons as a platform for producers and consumers of data to come together, to reduce the friction for creating good, clean data sets, and for reducing the friction in discovering this data, understanding where it comes from, understanding how you need to adapt, for example, when one of the underlying data sets change. we take an open source approach to it. We take, the approach of curating a set of data tools that come into it. And ideally, what we want is to get this, federated governance, which really means that, you have a set of rules that you set up on a platform, and you have, all the participants kind of decide how they apply. And, kind of like we want, and the self-service component, which really means that we give everyone access to resources as they need for running a data pipeline, for running, for example, a Jupyter notebook, for running the different things that they need to do their job. Now, I don't want to talk more about it because I have a whole session about it right after this in this room. So right after lunch, I invite you to participate, and I'm going to hand it over to Richard.
Definitely come. You'll learn a lot from what Marius and the teams have built. My background, besides running our financial service business and working in banks for 30 years, is actually heavy in the, I hate to call it AI, machine learning and data science space, right? So what I thought is I would give you a couple illustrative examples, assuming you have data, or we have a data environment that everyone can get access to in a very, democratized way. I'll give you two examples of projects which sort of hint at what AI can do to address a lot of problems. The BIS, the Bank of International Settlements, they're basically the global regulator. All the central banks are members. I've given numerous talks there. It's a very interesting institution. And they have innovation centers. There's 7 of them around the globe. And this is one project which is with the European Innovation Center, which was the Bank of Spain, the Deutsche Bundesbank, and the ECB. So what they saw was this lack of standards of getting data and metrics, right? So instead of waiting for everyone to come up with a standard measure, and everyone does this because it's taking a decade, if not longer, they decided to apply AI. So large language models, they looked at 175 different companies in something like 20 or 30 different countries, very, very different standards, and they used AI to come up with a proxy of what it looks like across all the firms. Anyway, it'll come back up. I'm not sure what's going on. But what that means is that they're able to synthetically create measures and metrics that they can compare an institution in France with an institution in the Middle East with an institution in the US, right? So again, it's not a perfect solution, but where we have imperfect data, or in some cases no data, AI allows us to address some of the challenges so that at least we can start to look at what's going across the globe in terms of performance. Another example, this is with a very good partner of ours, a software provider called Simudyne. They've been working with Amazon to model the supply chain. Amazon's doing most of the modeling. They're using their tools. And as you can see, there's a whole series of requirements in terms of the data. Amazon, this is the North American business. So it's a very, very large supply chain they have to manage. And what they're trying to solve here is a way of optimizing the supply chain, not only in terms of efficiency, cost, time from distribution center to getting it to your home, but more importantly, they also looked at their carbon footprint. This is what I thought I really liked as an example. So it goes a bit in here in the details of what they're modeling, down to facilities, transport vehicles. They have data. One thing with Amazon and also AWS, they have data that's sort of unmatched at a scale. So you can imagine applying to AI to all of these fine data sets and then building some very sophisticated intelligence. How can you optimize and reduce your carbon footprint? And so again, another example where you're using AI, huge volumes of data, but addressing a key aspect of climate challenges, which is our carbon footprint. Okay. Then anyway, so I think what we want to, did we skip forward a lot? Yeah, that's it. Okay. So what I wanted to sort of align, OS-Climate is really designed to create the foundation to leverage AI with data that you don't have to replicate or purchase, 1,000 times over across 1,000 firms, right? We see this as basically the common data platform where you can get access to all kinds of data sets that small firms, large firms can access this data to build your own tools. But we're also, with this community, building sophisticated tools that your particular institution might not invest significantly on, or they already have a model, and you have a challenger model, right? So the goal is to try to bring a whole range of analytic capabilities, AI capabilities, out of the box for all of you to access, use, in addition to whatever you're doing inside your firms, right? So anyway, but
So yeah, you can really engage on three basic levels, and depending also where you stand as a contributor. So contribute code, contribute to developing their tools and use their tools. As a member, because even if as OS-Climate and FINOS, we host all of this, so we need some members, we need a little bit of funding, and ultimately the end game is adopting. Organizations, companies adopting the software to create better standards and open standards. You can engage in all three, or choose where you are in that value chain and engaging on that. On the next slide, I think there's some QR codes where scan them or take a picture, then you can scan them later. But we have weekly community calls that, for example, on Data Commons, there's a weekly call usually that Marius is running with a number of community members. You can find out on the left on GitHub, read everything. There's a lot of readmes on all those 4 projects, or you can join as a member. Red Hat was one of the founding members of OS-Climate, and join us. Having a lot of fun and doing a lot of good.
I'd like to elaborate a little bit on that because you called me out, Stephen. So, as you see, we love things that just work. After especially like everything, code, connections, screens, and so on. We're putting a lot of effort in developing code because we have we come from an open source DNA. We're very, very strong believers, not just in kind of thinking things through, but actually putting them in code and getting them to work. Not just prototypes, as you said earlier, but really code that you can take and run. When you look at something like the Data Commons, for instance, that's something that we developed on the one hand as a way for the different members to experiment with data, to experiment with this process of creating, deriving insights from data and then creating, new data products. I'm going to talk more about that. But, also sharing them with other work streams, so that they can use them and they can build new tools from it. But at the same time, it's designed in such a way that you can take it and run it in your own environment. We're strong believers that you should be able to reproduce all this work, and instead of kind of thinking of a big platform, having a more federated approach to things. Everyone kind of wants to do things closer to their data. So your contribution is welcome in every aspect. You try it, you don't find the documentation, you let us know. You want to contribute code, even better. You build a new data product, that's fantastic. And this is true for all the work streams in Data Commons. Just wanted to add that.
any questions? We've got 3 minutes, I think. Yeah. Okay. Yes, please. Yeah.
What measures are you kind of taking to keep the data relevant as with AI things kind of move very quickly? So what measures are you kind of taking to keep it relevant?
Yeah. Well, the sort of the hot term the past year and a half, agentic AI, where you have agents who are sort of, in essence, maintain systems. They're never going to be in big production now, right, in general. But when you think of something like a Data Commons with all kinds of data sources, you can imagine agents being given tasks to constantly sort of automate that whole process, You can do it in other ways, more traditional ways. But the agents then would be able to actually analyze the data coming across, potentially verify that it's consistent in behavior with before. If it's an anomaly, it can send it to another agent that goes back to the source and validate, if it's a data error. Very simplistic example. But that applies to the models as well, right? So you might have models that you've loaded up, but it requires data updates, it requires other things. So all of these things, eventually agents will be able to process and analyze and validate and check, right? The validation and checking in an intelligent way, to me, is sort of one of the secret sauces of managing, data, especially if it's coming from, you're accessing data from many, many different sources that you don't physically own or touch. Right? Some it could be government sources, could be private sources. So that process of being able to intelligently enhance the testing and quality of your data, I think, is one of the easy things to apply. Right? I don't know, Marius, if you have any other thoughts.
I think you're spot on. I would just add that in the past couple of years, we fell in love with large language models. So we kind of lived in the world in which AI was, like before that, it was just data and extracting insights and so on. And all of a sudden we kind of moved to this world where everything is labeling and prompt engineering and so on. And we started to see the limitations of that. So now I think we're kind of like moving back to combining, all the virtues that we have, from large language models and, with kind of more classic analytics. There are approaches, for example, like neurosymbolic AI that are kind of emerging right now. That are focused more on like, how do I kind of have this like natural language and kind of generative AI approach to exploring the space of possible solutions with deriving information from real hard data. And I think that's where I think, you're absolutely spot on, Richard. Like this combination of accessible, good quality data combined with efficient agents and efficient models is really going to shine.
Yeah. I mean, agents can be super sophisticated. We have one example where trading agents actually derive better algorithms than the humans have. Now, would anyone want to bet on those? Not today, but eventually. So the ability of us as humans to sort of find nuances, and with massive amounts of data, which no one had access to before, opens the door for all kinds of different things. And most of you are in the age where you're going to really take advantage of it over the next 10, 15 years. So just keep your mindset open about the possibilities, especially when applied to things like climate, right? It's something that's incredibly complex. It's many, many dimensional, right? And what I see AI agents or general AI being able to do, if you've tried to fix something in one spot with a regulation, how does that conflict with other areas? We need to, and this is what goes to the neural systems approach, you need to look holistically at everything that happens. And so if you push a button over here, does it cause a problem over here, right? And so this is an optimization exercise, ultimately. If you're trying to reduce your carbon footprint globally across all aspects of society, well, there's cost. So there might be easier things you can do that doesn't cost society a lot versus things, and still get a significant impact and benefit from reducing your carbon footprint. So this is where AI and mathematics and stuff you're looking at, that's the part that I think is exciting.
I have a question. Just on the topic of sophisticated models, because we just had a talk with NVIDIA as well about how...
Joachim, I know Joachim very well.
Yeah, on and off. Do you have things like that in your protocols or controls where, like, though they may be using sophisticated models, they are actually needed so you can turn off the reason to reduce the energy usage?
Yeah, I think physical risk would be the ideal example, which I think was there's a session to this afternoon. There's a session afterwards, I think, still. Oh, earlier. Okay, he's the person you should talk to, Matthew, and because the model is the intelligence, and then the other aspects of AI, like agentic AI, can start to think about how you can optimize this in a much more complicated way, But it's not a linear problem, right? You have to think of this as a giant matrix of all kinds of avenues, and that's the power of AI. It can look at all the different dimensions and patterns that even some of the basic machine learning models will never discover. The large language or agentic models will be able to decipher some of those patterns. So, yeah.
Yeah, I'm gonna put my red hat or my red hat. And we actually not just have similar things, we actually work closely with NVIDIA on these types of things. And I think part of the virtue of this community model is that we can bring this work that we do together in the community so that everyone can benefit from it. So these types of optimizations and these types of, kind of like reducing energy consumption for models and essentially reducing the compute effort in general, to make things easier. That's something definitely, on our mind. I wouldn't say, as I said, it's part of the kind of like part of the OS-Climate work stream, but also kind of a part of a larger preoccupation with the quality of AI.
I have a final question for you, Red Hat, and maybe before for the audience here. How many of you work for a big bank or a big insurance company? Show of hands. Oh, a lot of you actually. Okay. How many are like a consultancy, small consulting firm? Who of you are individual coders? Okay, 2. Great. So my question is, Red Hat is a pretty big company now, but it started on a small idea, or it started very small. It was Jim, and so what are you getting out of, giving to the community, putting in the time and effort and money, but still having a commercial business model? Because I think that's the question that everybody has at the end. What am I getting out of it if I contribute so much?
So let me ask Marius to talk from the technology side, and I'll talk a little more from the business side.
Well, we have 2 minutes.
2 minutes, just very quick sentence.
I'll do it in 1 minute, hopefully. I'll speak from my perspective as a developer. Like I spent a significant chunk of my career as an open source contributor, and and then I had the chance to work for 2 open source companies, and spend most of my career with Red Hat. And what do we get? First, it's very, very important that, so for us, advancing innovation is very important. Everybody gains. This is not, and this is not just kind of like saying that it's a matter of goodwill. It's a matter of being very, very, very pragmatic. Nobody gains from closing the code and closing these resources. It's very, very important to collaborate and build more robust solutions. The value that we have as a company, for example, is in a very, very different area. Like there's a very different, and to Steve's question, for a very large enterprise, for example, it's very, very hard to bring these solutions together and put everything and have everything checked, run, version, packaged, verified, and so on. There is very little value in that. This is where we bring value. But contributing new features, contributing new capabilities, bringing new ideas, that anybody can benefit from. And at the end of the day, expanding the market. It's something that everyone benefits. So if you're thinking of what's in for me, if I contributed, it is really creating. Ultimately, you're contributing to a market that you're an expert in. If you're thinking from that kind of perspective, and you're making the world better, and you're making the world more transparent, and that makes your life easier ultimately as a company. So this is kind of like, this is how we see it.
I also think you'll have millions of colleagues that you're working with, not just your colleagues in a single firm. That's what I find exciting about Red Hat. We're 21,000 people, probably 15,000 developers, computer scientists, and we actually work with millions of many of you, right? And tackling a problem like climate, OS-Climate, that's the investment we make, and it's there because not that we're going to make money off of it all. We're investing a lot of resources into it. The goal is that the outcome will be things that will benefit everyone, including Red Hat and IBM and other companies, right? So It's also just fun. It's a really, really fun way to work. Right? You know this. Most of you are in the open source space if you're here. So
So it's fun, it's better code, better technology, and it makes money.
yes,
So join.
yeah.
Thanks for that.
Thank you.